So we said that we can measure that with markers, 8-OHDG, lipid peroxide, 3-nitrotyrosine. If it goes on for a while, we may actually see damage happening within the cell. Cells beginning to die. Membranes breaking down. The body's not working properly. Now within our body, I said 90% of the oxygen that we use is going to be used for energy production. But small amounts of oxygen, 1 to 2%, if we're looking at the efficiency of an engine, that's pretty good, 98 or 99% efficient. But 1 or 2% of the time, that oxygen is going to start to produce these free radicals. It's going to take the oxygen and it's going to make free radicals. Now, as I said before, one liver cell has 1,000 mitochondria, and what we see in one mitochondria, there are as many as 3 million free radicals every day. So, one mitochondria makes 3 million free radicals every day, and there's 1,000 of them. In every single liver cell in your body, there are 3 billion, 3,000 million free radicals every day from every liver cell. That's a lot of free radicals, even though the machine is 99% efficient. So this oxidative stress can happen if there's an increase in energy production, if there's inflammation, if there's a lot of toxins, or if there's stressors going on in the body producing more and more cortisol. So this is what we've been talking about, and that is that we see how the systems, we step back and we say, oh, he's talking about energy production, and it has an effect on all of these aspects within the body. So all of these things can create oxidative stress. When there's oxidative stress, when there's free radicals that occur, the body's going to follow with an immune activation. There's going to be a stimulation of this molecule called nuclear factor kappa B, and there's going to be inflammation. And when there's inflammation, there's going to be damage that occurs to the cells. Now, one of the recurring themes you'll probably recognize from the week is the role of inflammation in the onset and development of disease. And here we see inflammation where it can come from the production of free radicals from reactive oxygen species. But we can do something about it. We can protect ourselves. The body has mechanisms to protect itself. It uses antioxidants like the vitamins and glutathione. It uses enzymes. These enzymes require specific kinds of nutrients in order to work. Specifically minerals like zinc and copper and manganese, selenium. We can use antioxidants such as we find through our foods, especially in the fruits and vegetables that we eat. Foods that are rich in color. And then our body is able to produce antioxidants as well, like glutathione. Glutathione comes from the protein that we eat. It breaks down glutamine, glycine, cysteine, puts them together, and allows the body and acts as an antioxidant. So we can see here that when there's a free radical, vitamin E and ascorbic acid and glutathione are necessary and useful for helping the body to hand off an electron to each of the different antioxidants to help to quench the free radicals that are there. So in trying to make this simple to understand, the way in which I think about it is I use in my mind, I think about R-E-D, and that is, what is the reserve? How much antioxidants do we have to be able to fight the problem? How are the enzymes working, and do they have the tools necessary to work properly? And is there any damage that's already occurring? So this is a picture of a laboratory report which looks at the top at the total antioxidant capacity. That's a way to simply be able to measure how much oxidative stress is going on inside the body at this point in time. I can also look at measures like glutathione here. Glutathione will tell me, recall that I said this is the most potent antioxidant that our body produces. Do you have enough of it? When it's depleted, you're more likely to have damage. So we look at glutathione, we look at the total antioxidant capacity. We look at the various enzymes, as we see here, of superoxide dismutase, SOD, and catalase. I don't want to go into all the details of these things, but we can see, are the enzymes working properly? If they are not, because they are taxed, running around trying to grab free radicals, trying to change everything each time, looking at the free radical formation from superoxide, which is a free radical, and trying to quench it. It's like trying to put out the fire all the time. If they become exhausted, or they don't have the selenium or iron or zinc or manganese that's necessary for them to work, they'll be depleted. That is a problem. That may be the source of where there's damage. And we can see the adverse effects in fats, in proteins, and in DNA. And we can measure each of these things. Total antioxidant capacity is a very simple blood test which can be done to look at what's the total amount of oxidation that you have going on in your body. And I can tell you for each of us that the amount of oxidation that we had on Sunday from walking outside was much, much higher than the amount of oxidation we had on Monday walking outside. Because the oxidation, the body is going to be trying to fight the pollutants that are present there, as an example. Now, if we have a good meal versus eating at McDonald's or Kentucky Fried Chicken, we're going to have more oxidants, and our total antioxidant capacity is going to go down. We're using up our antioxidants. So this is a simple measure of that. We can measure this glutathione that I mentioned, which is glutamine, glycine, and cysteine. We can see how much of that is present in the body. Again, a simple blood test that can be done. We can measure these enzymes and see how well they're working. Each of these enzymes is involved in helping to quench the free radicals. And we can see, is there damage? I've mentioned several times, we can measure damage in the fats. The way we measure damage in the fats, the most common form is called lipid peroxides. This has different names. We'll see in a later scientific slide, sometimes called TBAR, sometimes called malindialdehyde, sometimes called lipid peroxide. All the same thing. It means that the fat is rancid. Another way to measure it is isoprostane F2. Another way to measure it is to look at the cholesterol molecule and LDL cholesterol and see if it is oxidized. Many ways to look at oxidation in fat. We can look in oxidation of sugars by the presence of hemoglobin A1C, where there's oxidation that's happening on the red blood cell itself. We can see oxidation of the proteins with nitrotyrosine and damage to the DNA. I've talked about these. So I've just shared with you, well, there's things that can cause damage. What can we do about it? And the beauty of this is that understanding whether the damage is occurring from glutathione being low, or from the enzymes not working properly, or oxidation of fat, or protein, or DNA, it gives us different treatment recommendations. For instance, if your fats are rancid and oxidized, you want to use alpha-lipoic acid, or vitamin E, or coenzyme Q10. We also find that there are certain herbs, like curcumin. Cayenne and garlic also are helpful if you have oxidation of your fats. Now, if you have oxidation of your muscle, of your protein, that usually happens at a time when there is inflammation that's going on. So if there is oxidation of the protein, then you say, oh, there must be inflammation that's going on. I need to use anti-inflammatories to help with that. And I hope that you've learned that the best anti-inflammatory that we have in our functional medicine toolkit is the use of omega-3 fats. But of course, you want to understand what's causing the damage also. So we can use an anti-inflammatory like the omega-3 fats or curcumin to be able to decrease inflammation, but we also want to find out upstream why is there inflammation that's going on. And when we see further downstream when there's damage to the DNA, we see that this can often be due to toxicity and radiation. So when we see DNA damage that's going on, it means there's some toxins that are present that are causing this kind of damage. I need to go and look for toxins to be able to help. Now I'm going to use tools like the nutrients in alpha-lipoic acid and anti-inflammatories and antioxidants like green tea extract, epigallocatechin gallate, green tea, just drinking green tea, or drinking grape juice, or red wine, resveratrol, or eating plants that have a high amount of antioxidant capacity. Dr. Roundtree talked about these in his lecture yesterday morning. So we can treat the damaged DNA. We're going to look to make sure there's not excesses of iron, and we're also going to make sure that there's adequate amounts of B vitamins, because methylation is very important, and the B vitamins that are present there. Now, I've just shared with you 3 different ways in which damage can occur, and different kinds of targeted therapeutics that can be used. Now, I recognize that this is at a high level in terms of what I'm sharing with you. And we can go into specific doses of alpha-lipoic acid and curcumin and omega-3 fats to be able to help you with each of these steps in the process. And that's one of the things that your functional medicine laboratory can also help you to do, is to understand what are the specific treatments and what are the dosages that I can use. But each of these imbalances, whether it is a loss of antioxidant capacity and low glutathione, which means you may not be getting the amino acids that you need to produce glutathione, or a change in the enzyme capacity, which is going to require these specific minerals in order to work properly, or damage that's occurring, each of those things drive different decision making. different kinds of therapies that go on. So the effectiveness depends upon where the problem is, which is why when we talk about oxidative stress, we don't just have a one-size-fits-all super pill. And this is where the problem is with the old way of thinking, where we said if there's oxidative stress, just give more and more antioxidants. Just give more and more vitamin C or vitamin A or vitamin E. The doctors who you speak to, who are your colleagues, who understand nutrition, will tell you that you need to be very, very careful if you're going to be using, for example, high doses of vitamin E. High doses of vitamin E can actually create a problem. Recall that I said earlier from the great teacher Paracelsus, anything that is a medicine can also be a poison. And so we want to be careful when we target the use of vitamin A or C or E. When we use coenzyme Q10 or alpha-lipoic acid, the plant-based antioxidants that I've been referring to from green tea, from red wine and grapes, from milk thistle, from other kinds of herbs, as Dr. Roundtree talked about. We want to make sure that the B vitamin status is okay. Now, when I first learned functional medicine, or was learning functional medicine, my view was, well, I should just give all of these things to everybody all the time. And if it didn't work, then I needed to give higher doses of everything to everybody all the time. And that's not what functional medicine is. Because, recall that I said here, if you have problems with DNA damage, that's going to be one of your best bets to do. If you have problems with protein damage, you're going to want to focus on anti-inflammatories, not even on this page. If you're having problems with rancid fats, you're going to want to use things like alpha-lipoic acid and CoQ10. Those are going to be some of the best tools that you have. If you have problems with your enzymes, you're going to want to focusing on the minerals. If you have low amounts of glutathione, you want to be making sure that your body is breaking down the protein into the glutamine, glycine, and cysteine so that you can make glutathione. So you can see just on this page, there are differences in what kinds of treatments we use depending upon where we find the imbalance. And then there are generalized approaches that work for everyone, and that is, if you have a diet that is rich in color, the color has so many different kinds of antioxidants. So foods that are orange and red, like carrots and peppers and yams, these have carotenoids, lycopene, lutein. The berries that we eat have resveratrol and anthocyanins. The cruciferous vegetables have the sulforaphanes and carotenoids. So we see that eating a rainbow of colors on your plate will help to be able to give you all of the different kinds of antioxidants that are needed. So I've spent the majority of my time here talking about the background. And now I want to go through and talk to you about, well, what does this mean to the brain? But before I could start on the brain, I felt like I needed to help you understand, when I say oxidative stress, what I mean and what can be done. So we see that the brain, actually, because it's got such a high need for oxygen, such a high need for energy, that it is particularly sensitive to oxidative stress because it needs energy more and more and more. And if it's not getting the oxygen that it needs, it produces more free radicals and we have damage that occurs. So within the brain, we see that there can be different kinds of reasons for the production of reactive oxygen species. We see that one of the neurotransmitters using glutamate acts as it excites and activates the system. And the repair system within the brain is different than the repair system within the rest of the body. We don't have the same kinds of immunologic repair system. The microglia that are present in the brain that act to help with repair, they actually produce more reactive oxygen species. And one of those enzymes we talked about, catalase, isn't even present in the mitochondria that are inside the brain. So when we think about the brain, we think about neurons, like these big red cells that are there. And we see that they have neural clefts where there's information and neurotransmitters that are released. They receive information from the forebrain, from all the different parts of the brain. They're connected to each other. And that's generally what we think of as the brain. But I mentioned a cell called the microglia cell. And the microglia cell is part of the immune system inside the brain that's involved with repair. So it's helping to take care of and repair things, but it's also producing inflammatory markers, something we'll learn about in a moment called growth factors, as well as reactive oxygen species. So we see that when there is oxidation that's happening in the brain, or inflammation that's happening in the brain, or not enough energy production and the mitochondria are slowing down in the brain, this leads to degeneration. Now, I've talked about the different kinds of antioxidants that are present. There are natural antioxidants, and then there are also the things like vitamin E and CoQ10 that can be used. So we see that normally when there is oxidative stress, you'll note I've hit a few slides here from what would be my normal lecture to try to help emphasize what I think are the key points. There's much more information in your slides that you have there to be able to help you to deepen your understanding of it, but I want to highlight the most important pieces that are present. So it's not as though I'm skipping any information, I'm just emphasizing those things that are most important. So for instance, as we see here, normally there's a process where there's a production of reactive oxygen species. And that production, when it occurs, the body is going to react to it. It takes care of those free radicals through the enzymes, through the antioxidants like glutathione, and that's important. That's part of the repair process. It's happening all the time. It's not as though that's a bad thing or the wrong thing. We find that when we're moving along in our life, sometimes we're going in this direction and we say, oh, I wanted to go this way, and we make a small adjustment. That's what's happening in the body all the time. So that's an adaptation response, and that's what we would like to see. And there's a repair of any damage that occurs. But if you don't have the ability to repair because you don't have the right nutrients, or you don't have the right cofactors, or you have too much irritation, too much reactive oxygen species that are going on because of exposures, then we can see that there's this damage that occurs that I've been talking about, the oxidation of proteins, fats, and DNA. And when that happens, damage occurs, and we see that one of two things happens. Either the cell dies and says, I can't live anymore. Apoptosis means cell death. And if it happens to a number of cells, we see an area of necrosis occurring, of degeneration that's happening. Well, when that degeneration starts happening in the brain, we start to forget things. We have an impairment of our memory. We may have impairment if it's occurring in certain areas that are involved in our basal ganglia in the primitive brain. We may have difficulty with movements, as we see with Parkinson's disease. And we see, as Dr. Hyman talked about earlier, that when there are things like diabetes, which will cause mitochondrial dysfunction, we can actually see more irritation and more inflammation that goes on. So one of the things that we find is that limiting calories, going on a calorie-restricted diet, or exercising, both can have a beneficial effect with things like Alzheimer's disease. So we're going to learn that some of the factors that make the biggest difference in dealing with neurologic degeneration and loss of thinking capacity, cognitive dysfunction. We're going to learn there's 4 things that make a big difference. Calorie restriction, physical exercise, DHA, anti-inflammatory omega-3 fats, and mental exercise. Those are the things that make the biggest difference. We'll go through talking about the data that helps to show that. So this slide, kind of complex, shows how exercise, you may say, why would exercise do that? Exercise creates oxidative stress. Exercise, too much exercise, can be a problem. But a moderate amount of exercise stimulates the system, there's a stress response, and the body begins to produce various kinds of agents, including something called BDNF, brain-derived neurotrophic factor. This is the molecule that helps to stimulate growth, neurogenesis in the brain. It's protective to the brain. Now, when I was in medical school 30 years ago, they told me that once something happened in the brain and it died, it could never regenerate. There was no regenerative capacity inside the brain. But that was incorrect. There is a capacity for the brain to develop and to create new nerve growth, neurogenesis. And so we see when this pathway happens, there's an improvement in cognition. If you're starting to be forgetful, you begin to remember, and there's less disease. But